This year, we're doing a virtual homecoming week, thanks to the miracle of Zoom and a fantastic support team that we have here in advancement and technical support departments around PLU. I'd like to give a shout out to Bluestream Technologies, which is helping me from my home connect to you all on the internet, and all the data that's coming to you is coming one bit at a time through that pipe. If for some reason, however, the Bluestream internet service fails and goes down, it'll certainly give us something to laugh about in the years to come, and we'll do that. What you want to do if that happens, though, is stay on the line. Some of my colleagues will pop in and ask you some questions and entertain you while I reconnect. I'll be able to do that through one of my internet systems, I hope, or if I have to break out my 1993 Hayes Smart Modem, I will do that as well. Of course, that's mostly a joke, hopefully, but if we do go down, just hang in there. We'll be right back online as soon as we can. Along those lines, I wanted to introduce to you some of my co-hosts, Kathy Engel, Jessica Pagel, and John Strusenberg, who are here and helping us out. They will be serving as co-hosts for today's webinar. And if you ask a question through the Q&A feature at the bottom of your screen during this presentation, they will curate it and send it to me, and we will answer that when the talk is over. You may have a question about our topic here, which is related to personal computing and the Learn to Program movement in America. That'd be great. You may also have a favorite memory of hanging out with me or doing something at PLU, perhaps a loot memory of some sort. So please let us know what those are, and we'll chat with you about those. If we can't get to all of them, then we will email you. I will email you personally about them. So thanks. I know that some of my past students are out there, which is great to see. I hope you're doing well. And we miss you on campus, but it's great to reconnect with you. We also know that some family members are out there. So Mom, thank you for tuning in. I really appreciate it. My cousins as well, I think, are out there. It's awesome. Today's lecture theme comes from research that I've been doing in my position in the history of business, computing, and technology at PLU. And part of it relates to my role as Benson Family Chair of Business and Economic History and the work I do with innovation studies. And so my main topic today is, can computer programming be considered a social movement in American history? And if so, what would be the benefit of doing that as historians? And if that seems at all unusual to you, you might remember that historians are interested in studying change over time. And we do so because we recognize that a wide range of movements have altered human history, and change over time lets us see those things. Now, I've written some books about Europe's religious reform movements in the past and Italy's Renaissance movement, and I regularly teach at PLU about the scientific revolution and the industrial revolution, and movements that are related to the spread and institutionalization of capitalism in the United States. So computer programming is, I would argue, a similar type of revolution. It has had a wide impact on human activity over the past 60 years or so, not only in the United States, but around the globe. So computer programming has impacted education, business, politics, entertainment, healthcare, numerous fields. So I think it's worthy of study, but we might ask ourselves, does programming actually have a history itself? Like any social or business activity, computer programming also has a historic context. And although it's not usually recognized, programming has changed over time itself, not just in how people write their code, but in what people write their code about and what they do with their code, and also how they've learned to write programs. That has changed over time as well. The impact of computer programming is similar, perhaps, to the impact of the printing press. And one way of thinking about this is looking at the impact of software in history. Another way is to look at what people have done once they have developed the ability to write programs, or what they've done with coding skills when it's suddenly been added to their skill set. So what I've tried to do with the Code Nation project is explore how people have learned to program and what they've done with their new skills. A parallel to this might be studying the impact of automobiles in American culture by looking at how people learned to drive, which cars they drove when they did, and what they went and did with that driving ability. So yeah, I think programming can have a history. I also want to discuss today how learning itself, learning to program, could be considered a social movement. And to do that, we have to study a little bit about what social movements do, okay? Social movements typically have leaders who create a vision, and they have shared ideologies which act as a kind of roadmap for a collective activity. I think that's true for social movements like the Civil Rights Movement, and also for the learning to program movement, which has predominantly been visible in education and American culture. Within that context, there are organizational structures and dense human networks that have developed around teaching programming. And there have been activists, people who are really fired up. We tended to call them evangelists at Microsoft, who spread the word and developed agendas for action. And some of these agendas included calls for social reform, political action, educational initiatives, government policies, and so on. So yeah, learning to code can be considered a social movement if it fits some of these categories. Now, you may not have written programs yourself. I know a lot of people are in this call, and that is typical. There are a lot of skills in society that are exclusive to certain groups, but I wanted to define in just one slide what computer programming is. And some apologies to my colleagues in computer science whose entire discipline is now being turned into one PowerPoint slide, but here we go. What is programming? Well, programming is essentially problem solving with a computer. It's creating a sequence of instructions in a given computer language that automate a task or maybe find a solution to a problem that we would like to do a little bit faster, to make a little bit more efficient, and do many, many times quickly. Now, computer programming involves a lot of tasks, and the people here on the left on your screen are actually from Dartmouth College. This photo was taken in 1969, just outside of Dartmouth's computer center. So there's 3 people programming, and it looks like they're just staring at program code on a printout here. But what actually happened before they wrote their program is that they were doing planning and research, that they were using algorithms or these ordered steps that help them to solve their problem. And they were working as a team. A lot of us think of a computer programmer as a solitary individual staring at some sort of glowing screen. And unfortunately, right, in movies, that is often the image. There are not very many good programming movies. It's just really hard to find it. I guess the 1983 War Games comes as close as it can to like an action-oriented film in which the protagonist is trying to solve problems using programming. But really, rather than solitary activity, it's teamwork that helps people write code. And so by studying programming history, you're studying the history of teams and what they do. You're also studying how people solve problems with specific computer systems. So if you're a programmer, you get to know different software systems, different software libraries, and different hardware systems. And today in the internet, different contexts of client-server computing. Programmers also use software development tools. So just like a writer might use a word processor to write a novel, a programmer uses different software development tools to write their programs. And those can be just spread out into many different systems. The process of programming also involves things like testing or debugging, which means finding and fixing errors, understanding the defects in software, and then documenting the programs by writing books and manuals and codes, comments in code about what software does so that it can be updated easily later. Finally, people often are involved in distributing software solutions, either posting something up on the internet or sharing it with other people, like a game. Okay, so that's what programming is, if we're looking at the history of it. Now, let's take a minute to look at programming over time and see how it has changed over time. The first group I'd like to chat about briefly would be the folks that are writing code in the 1950s. And when that happened, we were really in the early days of personal computing, not personal, we were in the early days of computing. And the context would be something like we see here on the screen, which is Maurice Wilkes, who's kneeling there with his colleagues at the University of Cambridge in England. And rather than write programs using keyboard and typing in their code, these programmers were setting up their computer to do probably numeric processing or some sort of ballistic tests on like what a missile might possibly do. They were looking at well, they were wanting to do some pretty fast numeric processing, but they did it by setting up different registers, by actually physically clicking switches on the hardware. And this is Professor Wilkes and some of his colleagues, both research assistants and other professors. And it took a whole team to program this EDSAC computer, one of the very first general purpose computers. As time passed in the 1950s, people began to use languages like Fortran, which were general purpose programming languages, which allowed people to write code with a little less detail related to the computer hardware. An example of that would be Grace Murray Hopper, one of my personal heroes, who was an early programmer and designer of languages in the 1950s and 60s. And Grace Hopper is shown here by a UNIVAC 1 mainframe computer with some of her programming team. They're here by the console of the computer, so it's only part of the computer. And there is a keyboard actually on this device. So they're able to type in probably strings of numbers, either in machine language or assembly language, and tell the computer what problems it should solve. All right, so programming was starting to change in the 1950s, but what really made it a popular movement, and it is of interest to me in my book, Code Nation, is the work of someone like Daniel McCracken, who is shown here on the left. He was the president of the Association for Computing Machinery, or the ACM, which was an organization designed to help people learn about computers and program computers. And he was best known for teaching people how to program. So he wrote programming tutorials, and these sold in the thousands, actually hundreds of thousands. So his book in the middle, A Guide to Fortran Programming, I love the title, was very popular in the 60s and 70s. He was the first best-selling programming author. And if you're a historian like me, you're interested in how did people learn? What were the texts they used to learn? And how did those ideas about software get transmitted from generation to generation? Then you're looking at books like this. So you actually go into old research libraries or archives, and you try to find these old books and try to understand how they taught about software. Now, in an earlier part of my career, I was really interested in the Protestant Reformation and how ideas went from one generation to the next. So I did the same thing. I went to research libraries and I looked at the books that were being written, sometimes in other languages, and I would study how ideas were passed from one generation to the next, or how a pastor taught later pastors how to do theology and how to do pastoral care in Reformation Germany. In a way, it's the same thing. You find people who taught about programming, you find the books they wrote. But guess what I learned? I learned that in the 1960s, 70s, and 80s, all the books that people wrote, those are currently being discarded now by libraries because people think that's old technology. Why bother doing that? So people have actually stopped doing that now. So my work as a historian has become important because it is helping people to understand how people have learned to program over time. So Fortran became successful because of people like McCracken, who wrote these books and taught people to program. And in the 1960s, programming became a business proposition. As companies in America and elsewhere computerized, they began to set up computer systems to do data processing and billing and research. And the demand for Fortran and COBOL programmers increased, okay? And no longer was it an occupation that was sort of a side area of research, but it became a profession in American history. Now, it was an odd profession because, you know, at the time there were people like doctors and lawyers and accountants and pastors, for examples of professions that were regulated and controlled by standards organizations. So you couldn't be a doctor unless the American Medical Association approved you to be a doctor. That never happened with computer programming. Although in the 1960s, some organizations like the ACM tried. So did the IEEE. But they couldn't make programming an occupation that you had to have a particular certification. Now, that had happened with accounting. And so people had to pass the CPA exam and be licensed. Same with lawyers. They had to pass the bar exam. People tried to do that with computing, but it never stuck. And it's one of the reasons that learning to program has been so confusing over the subsequent decades. In the 60s and 70s, there were men and women involved in this field. And as this image shows from IBM in about 1960, there were women involved in management and in writing the programs. But that gradually changed as the organization was no longer regulated. And as the jobs started to get more expensive, basically men began to elbow out women. So one of the important things in computing research and understanding how people programmed is what happened with gender, what happened with racial identity, what happened with national identity as people learned to program. Were some people pushed out? And it turns out that that was the case. Over time, in the 60s and 70s, two images of programming sort of developed in America. And one was this image, which is a photo taken in 1968 of a software engineering conference that was happening. And notice in this picture that everyone is a man. As far as I can tell, everyone is a white male in this picture. They are all computer science professors or business leaders that were interested in integrating computer programming into businesses and into academic study. But they imagined a relatively small world of computing. That's what they imagined, okay? And another image began to fight against this over time as the 60s wore on, and that was the American countercultural movement, a movement that spread to other countries and involved people like the man in the black hat in the middle here, Stuart Brand. Stuart Brand was a self-professed hippie. He was active in Southern California. He was also super interested in technology. He was interested in tools and the best use of tools. And so he said, look, Americans should get to use tools, but they should use tools in a broad sense for social good. And the magazines that he put out on the left included the Whole Earth Catalog. Now, this is a 1970 edition of the Whole Earth Catalog. And it maybe some of you remember it, it actually sold in the millions of copies. It didn't have a lot about computing, but it had information about tools and the best way to use them. So you could learn how to build a yurt, learn how to build a septic system. You could learn more about keeping bees or giving birth. You could learn how to make electricity. You could learn how to garden. You could knit. Things like that were in the Whole Earth Catalog. He wanted to provide access to tools in an era before the internet. And really, this is almost like the internet 1.0 because it included something about everything. These people were convinced that technology could be used by the masses. The guy on the right, Lee Felsenstein, is still alive. He lives in California. He was a computing pioneer. He was very successful at developing early personal computing tools. He's actually shown here with a bullhorn that he created that allowed people in a social civil rights movement context to all communicate with bullhorns electronically. He was a civil rights pioneer, an electrical engineer, and a person who pushed programming forward. I actually emailed him and interacted with him as I was working on Code Nation. I also interacted with Ted Nelson, the guy who wrote the book on the left called Computer Lib. In the small print there, it says, you can and must understand computers now. He was active in the 1960s, 70s, and 80s. He's still active today. He's one of those computing pioneers who was convinced that computing should be a broad-based popular movement. He rejected the corporate control of computing and thought that computers should be used by the people. It was a popular movement, very much against this academic movement, which seemed to limit computing to a certain group of people. Seymour Papert on the right is a person who passed away just a couple of years ago. He co-founded an MIT artificial intelligence lab, worked at MIT for many years, brilliant guy. He started as an educational psychologist and was convinced that computer programming could be a way for young people to make cognitive progress in their lives. In fact, he thought learning to program would benefit every human being, no matter what age you were. He co-created the Logo computer language, which was designed to be used by regular everyday people. He created this little turtle device, which is a robot that the programming language could control. And he was a pioneer in getting computing into schools and getting people to program. He said the benefits to teaching programming to children would be phenomenal. There were people that followed his movement and they loved it. And they began to interact with computers in schools. So these kids right here in the 1970s are actually programming in BASIC. They're doing it on a time sharing system, not a personal computer. And there were people that were really connected to that idea that children would develop skills if they could learn to do it. Another person I focus on in my research is Bob Albrecht, who became a popular evangelist for the BASIC programming language in the 70s and 80s. Now, I think we have some people logged in tonight from Minnesota. Trent, you might even be out there. Some of my other cool relatives from Minnesota might be out there. Bob Albrecht spent time at the University of Minnesota. He was also in Denver. He started teaching people to program. He did it a little bit in Fortran, but he really took up BASIC when he saw a version of it demonstrated in Minnesota in the late 60s. This was a version of BASIC that was developed at Dartmouth for time-sharing computers. And he had a religious sort of awakening for computers. He drove out to the east or to the west coast, settled in the San Francisco Bay Area in 1969, got a red Volkswagen van and began driving around and telling people that they had to learn to program in BASIC. In 1972, he wrote this book, My Computer Likes Me When I Speak in BASIC. Sold it for $2, and it told people how to program using a time-sharing version of BASIC. He would provide access to some of these tools in his van. So he'd be the guy driving along and would say, hey kids, come over, look what I've got in this van. It's not candy, it's computers, right? And you're gonna learn to program in BASIC. So he was a super interesting guy that wrote a lot about computing, tried to get people to do it. He was also involved in counterculture protests and the environmental movement. Lots of his examples in his books are concerned about world population, okay? So he is one of the people that convinced me that programming was no longer a narrow activity that would be something that would only be done in universities and then corporations like IBM. But it was a broad-based thing. He started this organization called the People's Computer Company, which was a newspaper that began to distribute materials all around, particularly in the Bay Area. And this is one of the illustrations that they wrote up. It is framed by this BASIC is the people's language in the middle. But he also has used computers for people, not against them. And over on the lower left, there's a sign that says no more Fortran. He actually had buttons that he created a society that said no more Fortran, and he wanted to remove it. He thought it was terrible. Just take a moment and look at the connection between a sign like this and the civil rights movement in America. Both movements emphasized a broad-based coalition of people that are black, white, different ethnicities. There are children, there are older people with peace signs. There's the person holding BASIC is the people's language, is wearing like a construction site hat. You know, he's a laborer. And so this, to me, is powerful evidence that, at least at that time, people were trying to push computing forward as a broad-based movement. And people, you have to appreciate that Steve Jobs on the right and Steve Wozniak on the left, the co-founders of Apple, they were breathing this exact same air. So this was the era, the mid-70s, when people were starting to create devices that maybe could be distributed to people. This is actually the Apple I. It's a computer photo that I got permission from Apple Corporation earlier this year to reproduce. It was very interesting because I said, look, I'm writing this book. I love this picture. I know you have the copyright to it. Would you allow me to use it? And they said, yeah, but you got to show us the whole chapter that it comes out of because we don't want you to be dumping on Apple. And I said, no, I'm not going to dump on Apple. I'm just going to talk about their origins in the context of programming. So they gave me this picture to use. It's a picture of the Apple I kit, which was first created by Steve Wozniak on the left. And it was distributed to people without a monitor, without a keyboard. You had to supply those separately. In the small print over there, it says you can get it at the Bike Shop in California. And I talked to a guy who used this device and bought one and actually had Steve Wozniak help him fix it. His name's Mitch Waite. He's a computer book author in the Bay Area. Hi, Mitch, if you're seeing this. He's writing a book about this exact experience. But the computer language that they used when they used these first devices was the basic programming languages. And as the first devices came out, and this would be the Commodore PET computer, and the Apple II computer, and the TRS-80, and devices like that, they all used the basic programming language. They assumed that if you were going to buy a computer, you would program it. That's what you would do. This takes us into the 1980s, people, when personal computing starts to transform the way that people are running their lives. Not only are there professional developers out there, but scores of hobbyists and students, gamers, business owners. They're going to conferences like this. This is the West Coast Computer Fair in the early 1980s. It started in the late 70s, and it would attract people from all over the West Coast to show their computers. They would also take seminars about how to learn to program. Bob Albrecht was there. Another person that was there was this basic evangelist named David All, who was involved with Creative Computing magazine. He sold all kinds of books about basic programming. This basic computer games book in its different editions sold over 1 million copies, making it the best-selling programming book to that time. So you have 1 million people buying this book. And where did the programs come from? Well, he told people from around the country, send me these games and I will test them and then republish them. And he did it actually on DEC computers at first in a time-sharing context, and then in the personal computer era too, with this book. David All was very devoted to getting people to program in BASIC, and he had tremendous success. BASIC became this programming system designed originally just for beginners that millions of people were using in the United States. And it only continued when the IBM PC came out in 1981, and Microsoft Corporation created MS-DOS for that device and also supplied a version of BASIC with the computer as well. Now this is Bill Gates and Paul Allen in 1983 when they're talking in their offices in Bellevue. They had not yet moved to their Redmond campus. And they're just talking about how to manage memory in the MS-DOS operating system. This is DOS 2.0 they're working on. And they're trying to manage memory. That was definitely an issue. The books on the right are the manuals that you got if you got a computer like that, and one of them is the basic manual. So you'd learn how to write basic programs also. And after this, personal computing becomes a super popular vehicle for families, for entertainment. Now these ads are hilarious. These are ads trying to show the nuclear American family as it was perceived by some in the 1980s. For some, this will be an off-putting ad because it is not diverse and it is entirely goofy. It is trying to show families that are super excited about their computers and using them together. So the family on the left is playing games with the entire family, and then on the right, they're watching the kid do his homework. Now, how creepy would it be if you're the boy on the right in the red hair and his entire family is just watching you do homework up close all day long? It's just so weird, right? And on the left, you know, what girl wouldn't want her mom just hovering over her every click of the mouse? The point, though, is that computing is becoming a broad-based activity, and programming is kind of coming along with a lot of that. Now, IBM Corporation, we were talking about them as more conservative and corporate focused, but they also were starting to try to push out into this market. But IBM still imagined its devices to be used in pretty traditional settings. So here's the 1984 IBM PC Junior, a new PC that wasn't very successful. It was a little cheaper, and it had a case that allowed you to insert ROM cartridges into it, so you could have different software on these little cartridges and plug them in. But notice how IBM imagines teaching BASIC in very much a classroom setting with a middle-aged white guy standing, lecturing over people, teaching them kind of one-on-one in a lecture format how to program. And on the back, you probably can't see it on the chalkboard, but there is that computer program, and it's showing people how to toss coins with a computer and keep track of wins and losses, okay? All right, so they still envision programming to be a kind of a top-down. IBM will supply this to a teacher will teach, and they'll use IBM computers. I think what they didn't recognize is that people in all walks of life are starting to write programs. They're starting to become interested in programming. And we're going to leave BASIC now for a little bit and talk about really some other people that were coding. And if you would look at this Code Nation book that I worked on, yes, a few chapters are about BASIC, but there are many other languages and contexts talked about. And one of them relates to this interesting fellow, Peter Norton, who has not really been written about by computer historians yet, but until now, but is a person that is pretty well known. The box in the middle might be familiar to many of you. The Norton Utilities was one of the very first versions of commercial software that came out. Way back in 1982, Peter Norton, who lived in California, but actually had worked at JPL and in the aerospace industry, actually went to school at Reed College in Portland in the 60s. He took the knowledge that he had from earlier computing contexts, and when he got one of the first IBM PCs, realized he could write some pretty cool utility programs for it. This is a time when the PC had very few utilities. In fact, the first thing he wrote was an undelete program that allowed you to recover a file that you had accidentally deleted on your floppy disk. And there was just no way of doing that. There was no undo. He created that first utility by learning about the disk sectors on a typical floppy disk and learning how to recover the information that was in those sectors before DOS overwrote it again. So he started to use these skills to create commercial software, and he made money at it. He was successful at it. He wrote these Norton utilities that came out for each version of DOS. And that is pretty well known. Eventually Symantec bought out his corporation for millions of dollars, and he made good money. What is less well known, though, is that Peter Norton was a very good writer. And it so happened that in the early 80s, he was contacted by someone from Brady Books who said, hey, you've unlocked something important here about the IBM PC. You've written these utilities and you've shown people, you've learned yourself how to write these programs. Why don't you share that information with other people? Because there could be a huge untapped market of self-taught programmers that would love to write applications for the IBM PC. So he started to do that. He wrote some books for Brady, which was a very successful publishing house writing computer books at that time. And then in the mid 80s, also Microsoft Press. So this book, the Peter Norton's Programmer's Guide for the IBM PC, to the IBM PC, came out on the left from Microsoft Press in the mid 80s and eventually sold 500,000 copies. And so we know about Peter Norton's books because they sold like hotcakes. He developed this stance, you know, this I'm Peter Norton and I'm rolling up my sleeves and I'm here to help. He actually trademarked that and it became something that Symantec trademarked. But he was very successful at writing for software developers. He taught them how to use assembly language, eventually Pascal and C, to unlock some of the secrets of the IBM PCs. And later writers like Ray Duncan went on to do that very successfully. So with these computer books, we see people learning to program that had never learned before. Some of them took advantage of that and went to work for businesses, and others just use it for their own entertainment. Okay, so if you're looking at sort of this movement and its key texts, I think Peter Norton is one of the authors of those. By the 1990s, we have Microsoft Windows coming out. We have the Macintosh into its second and third generations. These visual programming tools are becoming popular, and many, many, many books are coming out that are becoming the conduit to this type of new information that is coming out. Millions of books and magazines are sold. Magazines like Macworld and PC World and Byte are getting that information out to the people. And in the 90s, still less than 50% of professional software developers in the industry studied computer science in college. So this self-taught movement, the self-taught aspect of the learn to program movement is getting people into industry, getting them jobs. Now, we still have non-traditional people that are doing this. One of my favorite is Judith Baling. We were able to write about her in Code Nation. She hasn't been discussed before because she seemed to be on the margins of traditional polite computing society, but Judith Baling, later known as St. Jude, is a fascinating person born in 1939, active in the 1950s and 60s in the civil rights movement, went with Martin Luther King Jr. in some of the Alabama marches, was arrested in Montgomery several times. And this is a picture of her on the left being arrested. She was an example of a person who was an activist, who had activist roots, who later got into computing. She studied Fortran, she studied C programming, she studied Unix, moved to Berkeley, and was involved in the Berkeley Unix project and helped them produce software there. Was involved in many early computing systems, some of the first networks that came out in the San Francisco Bay Area, and later became identified as what we would call a cyberpunk at the time. She co-wrote this book in the middle, the Cyberpunk Handbook, and also became executive editor of Mondo 2000, a really important alternative computing magazine that was really on the fringes of computing. So it mixed Unix programming with counterculture poetry, with drugs, with sexuality, and it was really sort of on the fringes of that society. So in my opinion, if you're studying a computing movement, it's best to not just study the center, which might be these basic programmers or people at IBM. It's best to study the periphery too and see how the periphery and the center interact with each other. So Judith Baling is really important in that way. I'm going to start to wrap up with a few concluding comments. First, I wanted to say something briefly about the 2000s and the 2010s, okay? So what makes learning to program different in the 2000s is that the internet arrives, okay? And so although computing had become a broad-based movement because of personal computers, it was transformed again when the internet came out. And in 1995, we see the first commercial internet browser that allows you to navigate through the internet using graphical imagery. And by the early 2000s, there had been a lot of disruption going on. Traditional information flows had been very disrupted by this new internet. So the computer book industry was strongly impacted by the internet, and its sales dropped by like 45 or 50%. Many traditional businesses, newsprint, magazines were all disrupted by the computing industry. But people began to program in new ways using the internet. And so there were new ways to learn how to program, new ways to learn about it. There were also new skills that were needed to write programs. We got into the era of client-server computing, and in terms of computer languages, languages like Java emerge, or Visual Basic and Visual C++, they become internet aware. And so I was active as a computer book author in that era, and I wrote some books that tried to do that for people, that taught people how to do that. And it did involve new skills. So learning to program meant different types of things. One quick thing would be that normally when you write programs for a PC or a Mac, you write very close to the hardware and you know all about the display of the Mac or the PC. In the internet context, you're less connected to the hardware, you're more abstracted from it. So new issues come up though, security and things like that. So the 2000s has been very interesting in terms of the learn to program movement. The 2010s, in the last decade, the major theme has been getting back to this idea of making programming a mass movement. And what we've kind of learned is that in the 80s and 90s, many people were benefiting from computing, but it tended to be men, white men, American-based men that had the privilege of an education or had been able to be involved in some of these self-learning systems. Fewer and fewer women graduated. In fact, the high point of women graduating with computer science degrees was 1984, when something like 43% of the graduates with bachelor's degrees in computer science in the US were women. And since then, the number went steadily down. Although some ethnic groups, some minority groups did benefit from computing, Asian Americans would be one. African Americans, Latino Americans lagged way behind. And in the 2010s, people made a big effort to kind of fix that or address that issue. Now this image here is showing a fabulous robotics class in which kids are working together to program a robot on wheels. And their instructor is a woman, and she is teaching them all, and boy, we need more and more teachers like that. New nonprofits, new organizations are starting to try to do that. One of my favorite is code.org. We've worked with them a little bit at PLU because we're pretty close to their Seattle headquarters. Code.org is emphasizing equity in programming, which is something that I'm also trying to emphasize in my work. And so they have very successfully brought computer education to girls, young women. Right now, about 50% of the people studying computer science now are young girls and women. And some of these posters are the resources that they use. Having people like Steph Curry, NBA champion, telling you that you should write code. It's a good thing to do. Microsoft's CEO is saying computer science empowers students to create the world of tomorrow. And so, the code.org initiatives are bringing millions of new people into computing. And I guess what I want to point out in my research is that, that is something that they're describing as a pretty new movement. And I would just argue that the movement to make computing a broad-based educational agenda has been going on since the 1960s. It was really pushed in the 70s and 80s by some fascinating computer evangelists that really pushed different languages and skills forward. And now we're kind of in the place where this is being globalized and it's more equitable, and it's a really good thing. Now at PLU, in our Innovation Studies program, we're trying to do similar things, right? These are our set of 3 posters that Megan, one of our students in Innovation Studies, designed last year. And if you're a PLU student, maybe you've seen these up and around. But we're using them to emphasize that everyone deserves a chance to be innovative, and that everyone can build a team and connect different areas of the university together and design solutions to the world's most pressing problems. And at PLU, because of our mission statement, that's what we're really trying to do, is address some of the world's most pressing problems and give the students the skills to do it, not only in a university context, but one that also fits with global contexts and with all the things that they have passion about, including their passion. We have a makerspace in which some of these ideas are happening in innovation studies contexts. Yes, we're doing a lot of this virtually right now, but to get people to be creative and to push for these issues with equity and creativity, you need, I think, spaces like this. So I want to conclude in just a couple of ways here and then have a few questions, okay? Learning to program seems to be a social movement to me, because in the 50s, there were some 15,000 programmers in the US. And by 2014, there were 18.5 million programmers in a global scale. So many of them are hobbyists. They're not professionals, which is great. Personal computing had a profound impact on this, pushing it forward. And yes, the educational movement itself faltered a bit in the 80s and 90s, but it has been reclaimed in the 2010s. And computer books and magazines and user groups, yeah, those were great, but many of those have been replaced now with websites and YouTube and code.org and many popular coding initiatives, which have also been fabulous. I think the best thing about this is studying computer programming as a movement, like studying the scientific revolution. It allows you to focus on people. Like this is Professor Renzi Kao here at PLU, and this is a session in which he's teaching young kids on our campus. By focusing on programming, you focus on people, which is where I think we should do it. And now we are entering the time in which we can have questions. You get to look at a picture of me from 1990 when I was working at Microsoft. And I want to see what kind of questions we have coming up. So I'm going to close my presentation right here, and you can look at my face, and we'll see what we've got. All right, so let's do it. Team, what kind of questions do we have? All right, so first we have Molly. Hello, Molly. Molly is not asking a question, but just trying to say hello to Dr. Halverson and all of us. Molly, yes, you graduated in 2008. How could that be? That was That was a while ago. You said you took 5 classes from me, and now you're putting it all to use as a middle school teacher. Well, she's thanking me for her support, for my support of her back in the day, and all the good times. But Molly is a great example. You know, I started teaching at PLU in 2003, and students come through and they do all kinds of amazing things. And it's just so cool to see people like Molly off teaching and doing well. Awesome, great stuff. All right, team, do we have any more questions that we want people to answer? See if anything else is going to upload here. All right, so we also have a comment or two that people would like to be able to access the video recordings later. So yes, the good news is that we're going to be able to provide access to those later, so people can look at that. I guess this recording will be there. Don't have too many bloops or to get out, and we just want to thank you so much for coming. I know there have been a bunch of people on this presentation, and I want to thank you for coming. I want to thank you for supporting research at PLU. It's important to us, and we are eager to share that with our students. So an example of that in this research project is that one of my students, Damien, he was a person who helped me on the first part of Code Nation. We did a Benson Summer Research Fellowship, and we got to talk all about counterculture computing in the San Francisco Bay Area. And he and I did that a whole summer, and then we he wrote up a beautiful research paper. He went off and got a job, and when this book eventually came out, you know, I mentioned him, and we've enjoyed looking at it, so it's been great. All right, time for a few more questions. If someone were to start learning coding today, what language would they use? And there are some people who are saying, we graduated in the 60s, so you know, what do they learn? It's really interesting that you're asking that question, because now many of the programming languages are visual. A popular one is Scratch, in which people actually learn programming by moving around conceptual blocks and things like that. Code.org, this organization, nonprofit that I've mentioned, in their Hour of Code, they get students writing programs by adapting popular games. So the game Minecraft, which has millions and millions of users, they've adapted so that people can play the Minecraft game and learn conceptual things about programming. And we're learning that it's a lot less important to know the syntax of words. Like back in the 60s and 70s, we maybe learned about the syntax of Fortran or Pascal or C, right? We were burdened by that syntax. But now people are focusing on logic and conceptual thinking. So there are all kinds of new ways that people would do it. At PLU, people are still learning to program in Java because our internet-aware contexts are important. They might learn JavaScript or Python. So those are some languages that people are learning. There is a question about which languages would be best for someone to learn as they are thinking about making coding and computer science their career. So I would say that still it's very important probably to take a look at Java and understand something about Java. People are learning C++, they're learning Python. Really, once you've learned one of these languages, then it's pretty easy to learn the other ones. So I would say this: don't focus too much on the syntax of the particular language, but think about the fundamentals that you're learning. And this is kind of a weird thing to think about maybe, but you know, computer programming and computer science are not synonyms. So computer programming is just one part of computer science. It's like one of the 5 important areas of computer science. So when people study computing and computer science, they study a lot of things that are beyond the fundamentals of a language. You know, they study more about algorithms and data structures. They study different numerical methods and think about all kinds of ways of using data. They think about security. They think about ethics. They think about history. So yeah, these are important. And I think for the person that asks, what industry trends should students be aware of as they prepare for the next chapter in life? Yeah, I think thinking about ethics has become really important. It's something that the Innovation Studies program at PLU does. So if a person has the opportunity to study computing in a university context, yeah, they should try to study philosophy, religion, ethics. They should do that in history and philosophy, also in computer science groups. And one of the reasons this is so important is that we're thinking a lot about artificial intelligence these days, and artificial intelligence brings up many ethical issues. And yeah, it's just important to kind of get going on that early on. You know, that was also happening back in the 60s and 70s. So I talked to you about Daniel McCracken, who was one of these early computer book authors. He also went to peace marches. He also was worried about nuclear proliferation. That was one of the biggest causes that he was involved in. And he said, I write books about computers to make money so I can spend the rest of my time going on peace marches. I thought that was super, super interesting to think about. Well, we are getting nearer to the end of our time together. I hope I've been able to answer many of your questions and chat a little bit about some of these issues that we're working on. Thanks so much for your support at PLU. It means a lot. Thank you for all those who have a connection to me. Let's chat over email and keep it going. I really appreciate it. And I want to thank you for your attendance here and sign off. So again, I'm Michael Halverson in the Department of History at PLU, and just very grateful for all of you, and thanks for spending time with us. Have a great homecoming.